Question 2 of section B is a pulley question. And before you even look at what they're asking, you might as well put the forces on the diagram. So that's what I'm going to do now. I have a particle resting on a table, so normal reaction R. I've got a few things connected by a string, so I need to mark all the tensions on. 2 at the pulley and each at the particle. I've got weight, 2 mg for particle A and 3 mg for particle B. And that's it, because it's a smooth table, so I won't have any friction. Now in part A, they want you to work out the acceleration of B. And we know that in this connected system, the acceleration of both particles is going to be the same because they are attached by a light, inextensible string, and the pulley is also smooth. The string is also taut. Okay, so what we can do is figure out equations of motion for particle A and particle B and see if we can solve for any unknowns. I know that I don't need SUVAT here because I don't have enough information to be able to use SUVAT. So the first thing I do is write down F equals ma for A. And it's moving this way when it's released, so I take that as positive. I have a resultant force of T, and its mass is 2m, and acceleration, I don't know, I'm trying to work it out. So I call that equation 1. Let's do the same for particle B, but I'm going to take down as positive because it will be moving downwards. My resultant force will be 3 mg take away T equals 3 ma, and that's equation 2. So to write these two equations, you get 3 marks. It's really important that you do that. Don't try to skip steps and just get to the combined equation straight away. Okay, so what we're going to do is substitute for T in equation 2 because it's not T that we want initially, it's A. So what I do is I write down 2ma here. Okay, so this is what my equation looks like now. 3 mg take away 2ma equals 3ma. I have an m in each bit of my equation, so I can just divide through by m. And I will move the minus 2a over to this side. So I get 3g equals 5a. And that means a equals 3g over 5 meters per second squared. Okay, so that's answered part A. In part B, we need the tension. Because we know what A is, if you look at equation 1 again, we can just put A here and then we'll know what T is. So using equation 1, we've got T equals 2m 3g over 5. Not really a lot we can do to simplify. So I'm just going to keep it 6 mg over 5. You can put g equals 9.8 into each of these expressions if you prefer. But I think it's easier to keep it exact because if you use it again later on in the question, at least you'll have the exact form that you're using. So your subsequent answers will be more accurate. Okay, so part C. What's the magnitude and direction of the force exerted on the pulley by the string? So let's highlight the forces on the pulley here. You've got a tension going horizontally to the left, and you've got a tension going vertically downwards. Right, so if you want the resultant force, just like you do in vectors, we can redraw the diagram like this by putting the end of one onto the end of the other. And here is your resultant. Okay, so it looks like, because we know this is a right angle here, it looks like an isosceles triangle, and because angles in a triangle add up to 180, you've got to have 45 there, haven't you? And the other one at the bottom here is also going to be 45. Right, so long as you mark on the 45 degrees somewhere, then you've pretty much answered the direction part of the question, because they ask you for the direction, don't they? Magnitude and the direction. You could be more specific and explain what direction. So you could say that it was 45 degrees below the horizontal, and the fact that it's in a southwest direction. But none of that was on the mark scheme. Just writing the 45 degrees or showing it in a diagram like this was enough. Okay, so what about the actual magnitude? Well, because we've got a right angle triangle, we can just use Pythagoras here. So the resultant force is going to be the square root of t squared plus t squared. And let's put in our expression for t. So we've got 2 times 36m squared g squared over 25. Okay, which is going to be root 72 mg over 5. And then that root 72 is just 6 root 2, isn't it? So that's the resultant force, the magnitude. Magnitude just means they want the positive equivalent. So we don't need to worry about plus or minus square roots here.